Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at function pointers or pointers to functions. This video is part of a larger series of videos focusing on pointers and how we can use addresses in the C programming language. Specifically, this is going to focus on how we can use the address of a function and pass that address to another function to allow us then to operate on different functions without writing additional code. So to begin with, you want to go ahead and obtain a copy of your function underscore pointers underscore 01.c. We'll take a quick look at it. You'll notice here that we have this same helper function, void function underscore pointer underscore 01 with a void input argument. The idea is this is going to act as a little mini main that will allow for us to drive this demo. The more important function here is the second one that allows for you to display the function values, where the first argument is going to be the address of a function that accepts double as an input argument and returns double as an output argument. So this allows for us to use then the address of functions like sine and cosine, as well as functions that we create as long as they adhere to that pattern. That pattern being that they accept a double as an input argument and return double as an output argument. Additionally, you'll see here that we're passing an x min, which is basically the minimum x in our domain, followed by the x max or the maximum x, and then the number of data points that we wish to evaluate this function at. And so you can sort of imagine that we will pass it, for example, the sine x function or the sine function from 0 to 2 pi, and we might say that we want to have 17 values. Now, additionally, I provided you with a couple of little helper functions here, this function underscore 01 and function underscore 02, both of which accept double as an input argument and return double as an output argument. And you'll see the corresponding equations that I'm trying to model here. And I've also provided you with the code and some additional structure in each one of these little helper functions. The idea basically is that this correlates to this formula and so on. Now, let's go ahead and copy over our function prototypes. And we'll add them to our list, function prototypes, as well as go ahead and copy the code over that I've provided for you and add that to the bottom of your source file. At this point, we can go ahead and close out the snips file, and we can update our triaging of our command line switches in our main to reflect the additional example. So we have else if string compare I of our argv square brackets 1. And then what we'll do is we'll simply use the name of this demo here, this function underscore pointer underscore 01 as our command line switch, much like what we've done in the past. And if that happens to match our argv square brackets 1, we simply make a call to our function underscore pointer underscore 01. Additionally, we can go ahead and update our help to reflect this as well. And we make the call to function underscore pointer underscore 01 example. I encourage you to spend a little more time with the help as you get a chance. But at this point, let's go ahead and build it, make sure that we have not introduced any additional errors. And now we can jump into actually making this work. So the first thing we want to do is take a look at the overall structure. The idea is that our function underscore pointer underscore 01 is going to make calls to our display underscore function underscore values. It's going to pass an address of a function, some minimum x, some maximum x, and the number of data points that we wish to provide. And it's going to return an integer. And that integer is going to demonstrate whether there was success or failure within the function. Now, the key thing to note here is that we need to make sure that our x-min is in fact less than our x-max, and we're going to just make the constraint that we have to have at least 2 data points. In other words, n has to be equal to or greater than 2. You could rewrite this and allow for x-min to equal x-max and have only one value, or n equal to 1 as a value, but we want to at least demonstrate that we can do this for 2 or more values in this example. At this point, let's go ahead and jump into writing our display function values function. And since we're going to return either exit success or exit failure, we probably should go ahead and get a results variable. And we're going to assign this as exit success for its initial value. And this will then allow for us to simply have return results. At this point, we can use this now in our triaging of the arguments to be able to determine whether the function itself is prepared to run successfully. Now, what types of things do we need to watch out for in this one? Well, we said we were going to pass an address to a function and then use it to display the values from the x-min to the x-max, and then n is going to determine the number of values. Spoken a little bit already about the x-min and the x-max and the n, but we really didn't talk about the function itself. And the idea is that we have to have an address to a function to be able to properly do this. And so the first thing that we want to do is we want to eliminate the possibility that somehow the user has managed to pass a null value as the first argument. And so what we'll do here is we'll simply eliminate this possibility by checking to see if f, or the function, is equal to null. And at this point, then we could go ahead and put a display here that says error invalid function address followed by a new line. And at the very least, we want to say our results then are going to be equal to exit failure. Continuing with the triage of these arguments as they come in, we want to make sure that our x-min is in fact less than our x-max. And so what we want to do is we can reword this another way by checking to see if our x-max was less than or equal to our x-min. And if that is the case, sorry, a little bit too much MATLAB here recently, so that display was meant to be a printf. Sorry about that, I just noticed that. We now want to simply print out a message here that says error x-min must be less than your x-max, and you could also consider putting in the values that the user provided using 2 placeholders for the x-min and the x-max. But either way, results are going to be equal to exit failure. We also said an additional constraint was going to be that n must be greater than or equal to 2. And so worded another way, if n is less than 2, we have a problem, in which case we want to simply print error must have an n greater than or equal to 2. And once again, results are going to be equal to exit failure. At this point, we are ready to handle the else branch. In other words, if we've gotten to this else branch, we assume that we have a valid address to a function. We have a valid x-min and x-max, and we have a valid n. At this point, what we want to do is we want to go ahead and break down then the x-min to X max domain into segments based on the n. And there's a variety of ways that we can go about doing this, but probably the easiest to understand initially is to go ahead and create a couple of additional variables. One is going to be a X delta, and the other one is going to be a integer that we are going to call index that will allow for us to seed a for loop that will allow for us to loop through values from X min to X max. Now, at this point, we can go ahead and calculate our X delta by simply looking at the value of X max minus X min, and then dividing it by n minus 1. Now, the -1 part might seem a little strange to you, but you want to remember that there are 13 tick marks on a 12-inch ruler. There are 101 yard markers on an American football field, which is 100 yards long, and so on. So the relationship between the number of data points you want and the number of segments or sections will always be n minus 1, where n is the number of data points. At this point, what we can do is we'll go ahead and build a for loop. We'll start off with index equal to 0, and we will continue while our index is less than n, and we will simply increment our index. And then inside of here, then what we're going to do is we're going to build a relationship then between our current X and our X min and our X max. Now, if it helps you out a little bit, we can actually go through the extra step here of creating another variable that might be useful. We're going to call this X current, and our X current will simply be our X min plus index times whatever that X delta is. So basically, every time the for loop runs, we are going to increase the value then in parentheses, and we're going to add it to our X min. And then by the time we get to the end of our interval, then we will have then reached X max. Now, you do want to be careful about round off error here. So note there may be round off error, but we won't ignore that for this particular example. You can also do this with a for loop using the variables directly, as well as a while loop. Once again, use the pattern that makes the most sense to you. Now, we're going to print this out into a nice little table, which means that we probably should go ahead and add a couple of headers here. We'll start off with a X, and I'm just going to continue with our math theme and call this Y, or put another way, let's go ahead and do f of X, and then probably a nice table border. And we'll probably need to play around with this to see if we can get this right. Then put one at the bottom. And then additionally here, we're probably going to add a second new line just so that we have some delineation between the tables that we print out. Now, inside the for loop, I simply want to print out two values. I want to print out the X value, or the X current, and then I also want to capture the return value from whatever function that I have called. And this simply lends us to creating another variable that we are going to call Y current. And the idea here is that Y current is going to be the output of whatever function we have called. And so to see this, we'll simply say Y current is equal to f of X current. And that essentially is us calling whatever function was passed to us and passing the X current value. Now, once again, remember that this function f, whatever it might be, has to accept a double and must return a double. So we'll just put this here in some notes here: accepts a double and returns a double. That's the trick behind this. Now, hopefully you can see now the pattern or the benefits of this approach. The idea is that I can pass any function that follows this pattern. this point, we're simply going to have a nice printf here. I'm going to stick with %f just to keep it nice and generic, and tab over a little further, %f followed by a new line. And we're going to have for the first placeholder x current and y current. And I'll tell you what, we're going to make one slight improvement before we even run this. I'm going to go ahead and throw in the index here because I think it's going to be interesting for us to see how this plays out. I'm going to go ahead and lengthen my table just a little bit. And then for that first placeholder, let's go ahead and make a quick change here. We're going to put in %d. And like I said, we're probably going to end up having to realign this. But that first placeholder then will get our index. Now, that's completely optional, but I think it'll help us in our example a little bit. So go ahead and build it. And then since we have this working so far, we aren't calling it yet. It's time for us to jump into the function underscore pointer underscore 1 that's ultimately going to drive this little helper function here. And let's go ahead and go through some examples here. We're going to start off, we'll actually do several of these. We're going to first declare a results variable, and we're going to use it to call our display function values. And we're going to first start off with sign. And for our x min, we're going to pass it a 0.0. For our x max, I'm going to use the constant for pi. And I'm going to go ahead and break this up into 17 values. And I tell you what, I'm actually going to go ahead and do 2 pi. Hopefully we'll see the entire domain there from 0 to 2 pi. And likewise, before we even run this, let's go ahead and do a second example here where I'm going to change this now from sine to cosine. And so you'll notice a couple of things here. I'm not specifying the address of anything. I'm literally just calling that sine function, and C is then understanding that we want the address of the sine function or the address of the cosine function. Probably wouldn't be a bad idea as we start building this to go ahead and put some extra print statements in here. What if we say calling sine function, and then calling cosine function. Let's go ahead and build it once again, make sure we don't have any errors. And then the last logical thing to do would be to go ahead and print out whatever those results happen to have been. So there's going to be results, colon, and then a %d, followed by a new line. And then whatever the value is in our results variable. All right, well, we should be set to go. Let's go ahead and build it one last time. Let's go out to our command line. Make sure that you are in the correct location. You'll see there's my pointers demo. If we run it with no switches, we should see that our help has been updated to reflect the addition of the function underscore pointers underscore 1. And hopefully we don't have any logic issues here. If we run this function underscore pointers underscore 1, we should see our function. All right, so we seem to have something wrong in our main here, either that or I've typed something wrong. So let's go up to the main real quick. And let's see what we have misspelled. Plural. Okay, so what we want to do is we want to keep consistent here. It's function underscore pointer underscore 1. So I basically just called it wrong. That's easy to fix. So function underscore pointer underscore 1. And you'll see that I have two tables printed out. The first one is the result of passing sign, or the address of sign, to our little helper function. And our helper function then populates sign or calls sign using values from 0 to 2 pi. And on the right side of the table, you'll see the values associated with the sign of x in this case. All right, same thing with cosine of x. Note here that we are doing this in radians. And so if you take a look here, you would expect to see the sine of pi would be -1 and so on. And so it looks reasonable. About the only thing we have left to do is probably clean up our table just a little bit. And so why don't we go ahead and do that before we make any additional calls. Probably just go ahead and practice our tabbing a little bit here. Let's see how that looks. And once again, you can play around with this a little bit more, but that's already a huge improvement. You can go ahead and align these up a little better by providing some additional total formatting for the plus and minus, as well as for the integers for the index. You'll notice here that I'm starting off with 0 and I'm going to 16. In both of those cases, we specified n equals to 17, so we have 17 data points. Everything seems to be behaving like we want it to. Now, let's go ahead and call our two additional functions, our function underscore 1 and our function underscore 2. And what we'll do here is we'll just go back up here to our little helper function underscore pointer underscore 1. And we'll go ahead and make a printf that says calling function underscore 1. And I suppose it's a little redundant to call it function underscore 1 function, but to keep consistent. And we already know that we're going to do the same thing with our function underscore 2. Likewise, we'll say results are equal to display function values. And in this case, we are once again simply going to type in the name of the function, and C will take that to mean the address of that function. We're going to start with a value of 0 for the x min. We're going to go to 1. And why don't we specify 11 data points here? The idea is I want to get them in 0.1 increments. And just like before, we can go ahead and print out the results. And we can duplicate this as well for our function O2. And I encourage you to play around with the values for each of these. So I'm just sticking to 0 and 1 to keep this example simple, and 11 as the number of data points. But once again, have some fun with this. Let's go ahead and build it. We know that we should now see 4 tables. And sure enough, we do see 4 tables. We actually see a little extra noise in this that you can choose to turn off. You'll see here that it actually has some additional text. The source of that additional text is simply these extra print statements inside of our function O1 and function O2. You could argue that for what we're doing with this, they're probably a bit excessive and redundant. But you'll see that now I have a nice little table for both my function O1 as well as my function O2. Now, keep in mind, the reason I was able to do this is because our function O1 and function O2 both contain, or both have rather, the same function signature as our sine and cosine. They accept a double input argument and they return a double output argument. And for that matter, we could use any function that follows that pattern. Now, I'd like to do one last thing. I'd like to make an alternate call to one of my functions. We'll once again, we'll focus and we'll pick on our sine function. This time around, though, what I'd like to do is I'd like to demonstrate how you can actually use a variable to store the address of a function. And to see what I mean, I'm actually going to create a new variable with a double. It's going to be actually going to be a double. It's going to be a pointer to a function. And the trick is that the function must accept a double. And so what we're doing is now we're creating a pointer or a variable to store the address of a function that accepts a double and returns a double. Now, the idea here is that I can assign then to the variable f the sign or the address of the sine function. And so as long as it follows the pattern, double for a return, and then double for a input argument. At this point, I can, in this case, print f. I'm going to say calling our f function, whatever that may happen to be, and results are going to be equal to, display underscore function underscore values, and I'm going to pass the f to it. I'm going to once again specify 0 as my x min, and in this case 2 times our constant for pi. And then we'll change this up just a little bit. How about if we do 33 values so we see a little bit of variety? And we can once again just simply print out the results to confirm that our function was in fact working correctly. And just we can optionally go ahead and cancel, or excuse me, comment out all of these. We'll go ahead and build it. Come out here to the command line. You'll see I have a much longer table now with indexes going from 0 to 32, values going from 0 to 2 pi, and you'll see there is my f of x. And at this point, what I'm doing is I'm passing whatever value is stored in f, which happens to be the address of the sine function. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.